Let's explore file checksums in Linux. This presentation will cover verifying file integrity using the MD5sum and SHA-256sum commands. We will discuss file integrity, security, and verification. Checksums are fixed-size data values. These are created by running a file through a cryptographic algorithm. Checksums act as digital fingerprints to verify a file's integrity. Checksums help detect accidental changes or corruption. They also help in verifying that downloaded files are authentic. And checksums also help identify malicious modifications. MD5sum computes and verifies MD5 message digests. It is commonly used to verify file integrity and authenticity. To generate an MD5 checksum for a file, you can use the command md5sum followed by the file name. For example, md5sum filename.txt. This will output a 32-character hexadecimal number, followed by the file name. To generate checksums for multiple files, you can run md5sum, followed by the file names. For example, md5sum file1.txt file2.txt. This will output the checksum for each file on a separate line. MD5, which stands for Message Digest Algorithm 5, produces a 128-bit, which is 16-byte hash value, typically expressed as a 32-character hexadecimal number. However, it is important to note that MD5 is considered cryptographically broken and unsuitable for security applications because it is vulnerable to collision attacks. For security-critical applications, use SHA-256 or stronger algorithms instead. SHA-256sum computes and verifies SHA-256 message digests. It provides stronger security than MD5 and is recommended for security-critical applications. To generate a SHA-256 checksum for a file, you can use the command SHA-256sum, followed by the file name. For example, SHA-256sum filename.txt. This will output a 64-character hexadecimal number, followed by the file name. To generate checksums for multiple files, you can run SHA-256sum, followed by the file names. For example, SHA-256sum file1.txt file2.txt. This will output the checksum for each file on a separate line. SHA-256, which stands for Secure Hash Algorithm 256-bit, produces a 256-bit, which is 32-byte hash value, typically expressed as a 64-character hexadecimal number. SHA-256 is cryptographically stronger than MD5, resistant to collision attacks, widely used for security applications, and is recommended for verifying software downloads. Here are common ways to generate checksums for files and directories. To generate a checksum for an individual file, you can use the command md5sum importantfile.iso or SHA-256sum importantfile.iso. You can also save the checksum to a file by using the command md5sum importantfile.iso greater than symbol importantfile, md5 or SHA-256sum importantfile, ISO greater than symbol importantfile, SHA-256. To generate checksums for multiple files at once, use the command md5sum file1.txt file2.txt file3.txt. You can save checksums for all files in a directory by using the command md5sum star txt greater than symbol checksums, md5 or SHA-256sum star txt greater than symbol checksums, SHA-256. Note that the output format is always checksum followed by file name. Here's how to verify file integrity using saved checksums. You can manually compare checksums by generating a checksum for a downloaded file using the command SHA-256sum ubuntu-24.iso, and then comparing it with the expected checksum from the website. If the visual comparison shows they match, that means the file is intact. However, this method requires careful visual comparison, which can be error-prone for long checksums. You can also use the -c or check option to verify against a checksum file. First, create a checksum file using the command SHA-256sum file.iso greater than symbol file, SHA-256. Then verify the file later using the command SHA-256sum-c file, SHA-256. If the file is OK, the output will show file.iso:"OK. If the file has been modified and the checksum does not match, the output will show file.iso:"failed. SHA-256sum warning. One computed checksum did not match. The -c option works with both MD5sum and SHA-256sum commands. Let's explore some additional options and techniques for working with checksums. To generate checksums for all files in a directory structure recursively, you can use the command find/path/to/directory, -type f, -exec SHA-256sum, open curly brace, \, semicolon, close curly brace, greater than symbol checksums to SHA-256. To verify all files in a directory structure, change the directory to the path using the command cd/path/to/directory. And then run the command SHA-256sum-c checksums SHA-256. Use this technique for backing up important directories. Some useful flags for MD5sum and SHA-256sum are: to check quietly and only report errors, use the command SHA-256sum-c-quiet checksums SHA-256. To ignore missing files during verification, use the command SHA-256sum-c-ignore -missing checksums SHA-256. To check files with Windows-style line endings, use the command SHA-256sum-c-ignore -missing-w checksums SHA-256. To ensure consistent results across platforms, use binary mode with the command SHA-256sum-b important file ISO greater than symbol checksum SHA-256. And then use the command SHA-256sum-binary-c checksum SHA-256. Here are recommendations for effective use of checksums in Linux. Always use SHA-256 instead of MD5 for security-critical applications. Always verify downloaded software using checksums from official sources. Store checksums separately from the files they verify. Include checksums when distributing important files. Create checksums before backing up critical data. Use binary mode -b when working across different platforms. In summary, MD5sum and SHA-256sum verify file integrity. SHA-256 is more secure than MD5. Use the -c option to verify against checksum files. Checksums help detect file corruption and tampering. For additional resources, refer to the man pages for MD5sum and SHA-256sum and the new coroutines documentation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.